If you want to excel in maths and science, then do click on the link given in our description box and visit on the website of Infinity Learn by Sri Chaitanya, and do enroll on our Don't Memorize course, which you can avail up to 90% discount. Here you can enhance your maths and science skills with the help of our conceptual videos, flashcards for quick revision, mock test as per latest pattern of your exams, with 24/7 doubt clearance sessions with the facility of masterclass. To get extra 10% discount in addition, you can use our coupon code, that is NT10. So for more details, check out the link given in our description box. Hello everyone, so in this video we will be talking about nuclear charge, in which we are going to cover these subtopics. Our first topic will be nuclear charge, second will be what is ionization energy, and after that our third subheading will be ionization energy depends upon which factors. So here comes our first topic, that is nuclear charge. So what do we mean by nuclear charge? So friends, the nuclear charge is mainly defined as the total charge in the nucleus due to the presence of positive charged protons. As we know that in any atom, this nucleus consists of protons as well as neutrons. Protons are basically positively charged and neutrons are neutral in charge, and these blue dots are known as our electrons that have negative charge. So due to the presence of these protons here, the charge of nucleus will be known as the nuclear charge. So let me recall this for you once again. The nuclear charge is defined as the total charge in the nucleus. Okay friends, so in this nucleus we have neutrons as well as protons, and protons are positively charged and neutrons are neutral in charge. Therefore, the presence of protons that were positive in charge here nucleus, that's why the charge of nucleus will be known as our nuclear charge. So let's move ahead with our next topic. Our next topic is concept of ionization energy. So as you can see here, there are mainly three states of magnesium that we will be talking about. Our first is ground state, second is excited state, and third will be our ionized state. So as in ground state, electrons have lowest energy. So now we will provide 700 kilojoule per mole energy to the magnesium atom here, and then it becomes into excited state. And then in excited state, as electrons here now gain some energy, and now it have more energy as compared to our ground state. So now we will provide 738 kilojoules per mole energy to this magnesium atom, and then it loses its electrons. Then the electron of this valence shell will be lost, and here our magnesium is in ionized state. So by which we can say that 738 kilojoule per mole is the ionization energy of the magnesium, because this energy ionizes magnesium atom here. But why 700 kilojoule per mole cannot be called here as ionization energy? So the answer is because it cannot ionize magnesium atom here. As we have seen here, in ground state, as electrons have their lowest energy, then we provided 700 kilojoules per mole energy to this magnesium atom. After that, the electrons of magnesium have gained some energy, but they were unable to remove their electron from the valence shell. That's why again we provided 738 kilojoule per mole energy to magnesium atom, and finally it loses its electron. That's why it will be our ionized state, and 738 kilojoule per mole will be our ionization energy. That's why we can say here that an ionization energy is the energy that ionize isolated atom like magnesium. So now the proper definition you can write here is the minimum amount of energy required to remove the outermost electron of an isolated gaseous atom to form its cation, and cation means your an atom having positive charge. So after it, a question arises that why is ionization energy measured in isolated gaseous state? So the answer is really very simple. Isolated gaseous state means that an atom is present in ground state, whereas in solid or liquid state it may be combined or in bonded state. For example, you can see here we have taken an example of bromine. Now if you want to find the ionization energy of this bromine in this bonded state, then here very high ionization energy is required to remove an electron from this bonded state. then here we required a very high ionization energy to remove an electron from this bonded state, and it will be the correct value for ionization of bromine. So very high ionization will not be required. Hence, to find the ionization energy on bromine, we take isolated gaseous state of bromine, then find its ionization energy. Therefore, we say that ionization energy is measured in the isolated gaseous state. So let's now discuss what is first ionization, what is second ionization, and what will be our third ionization. Consider magnesium at ground state level, then we will add 738 kilojoule per mole energy to this magnesium atom, and then it will lose one of its electron and become unipositive ion, by which we get our first ionization energy as 738 kilojoule per mole. And remember this, in first ionization energy, ground state mainly converts into unipositive ion. Secondly, we have taken this unipositive ion of magnesium, and then we will add 1450 kilojoule per mole energy to this magnesium atom, and it will lose another atom and will become dipositive ion. So this 1450 kilojoule per mole energy will be known as our second ionization energy, as it converts from unipositive ion to dipositive ion. Now thirdly, let's take dipositive ion of magnesium, and then we will add 7732 kilojoule per mole energy to dipositive ion of magnesium, and again it will lose another electron and will become tripositive ion. So this 7732 kilojoule per mole energy will be then known as our third ionization energy, as it converts our dipositive ion into tripositive ions. So as you can see here that third ionization energy is mainly greater than our second ionization energy, and second ionization energy is mainly greater than our first ionization energy. Now let's learn and see about the factors affecting ionization energy. So here mainly we have taken three factors. Our first factor will be this shielding effect atomic radius. Now considering hydrogen and potassium, then the atomic radius of hydrogen is much smaller in size than potassium, as it is larger in size. So it will be hard to remove electron from this hydrogen as when compared to this potassium. And in potassium it will be very easy to remove this electron. So by which we can say that when atomic radius is smaller, then the ionization energy is higher, and when atomic radius is larger, then the ionization energy is low. So you can say here that there is an inverse relation between atomic radius and ionization energy, and there is also an inverse relationship between shielding effect and ionization energy. Secondly, now in nuclear charge, as considering lithium and fluorine are examples, there are mainly 3 protons and 3 electrons in lithium atom, while in fluorine there are 9 protons and 9 electrons. They both have 2 shells. So the size of fluorine is smaller than lithium because of greater nuclear charge. So it will be easy to remove an electron from an atom. So the small nuclear charge means smaller ionization energy, while it will be very difficult to remove an electron from fluorine, as it has greater nucleus charge, which means greater ionization energy. So remember this point, it will be vice versa. As we have a small nuclear energy, it will mean smaller ionization energy, and when it will be greater, then it will have a greater ionization energy, by which we can say here that it will have a direct relation with nuclear charge. So whenever your nuclear charge will be small, then the ionization charge will also be small, and whenever it will be greater, then both these nuclear charge as well as your ionization energy will be greater. So there will be a direct relationship between nuclear charge and ionization energy. Thirdly, if we talk about the nature of orbitals, as we know that s orbital is near to the nucleus as when it is compared to p, d and f orbitals. Ionization energy will be high in s orbital as it is closer to the nucleus. Therefore, the ionization energy of s orbital will be high if you want to remove an electron from s orbital, and it will be low in f orbital. So that's all for today, friends. I hope all the concepts of this video is clear to you. So see you all in our next video. Till then, take care. Have a nice day.